Hey guys, welcome to lesson 7b. I can dilate an image, identify a scale factor, and determine if a dilation was an enlargement or a reduction. So guys, you have heard of the word dilation before, probably when you've been in to get your eyes checked, right? And they put that awful liquid in your eye and it makes your pupils enlarge and it generally is fairly uncomfortable, but that's where you have seen the word dilation probably the most. Well, a dilation is where we basically shrink or enlarge a figure by some scale factor. Therefore, dilations are actually really closely related to similarity because a dilation, by enlarging and shrinking of shape, is going to create a similar figure, but not a congruent figure. And what we're going to do is actually dilate around a specific point where each point, the distance from that point, from each point on the figure to the center of dilation, the distances are all going to increase by the same amount. So you'll see as we get going. And our scale factor for our dilation is is always going to be in the ratio of the image over the pre-image, okay? So what we start with is always going to be in the denominator, and where we're going is going to be in the numerator. So an enlargement is where we enlarge an image and it ends up with a scale factor that is greater than 1 because the image is larger than the pre-image, and we always divide image by pre-image, so the larger numbers in the numerator making it greater than 1. Whereas a reduction is where we shrink our image. It gets smaller. Therefore, our scale factor is going to be less than 1 because in our ratio, image over pre-image, the smaller numbers in the numerator, making it less than 1. And here you can see how we dilated a triangle with side lengths 1 and 1 around we dilated a triangle with side lengths 2 and 2 around a point of a center of dilation right here, and that each side length actually shrinks half to half. So my scale factor is actually 1 over 2 for this guy. And so he would be a reduction because the image is smaller than the pre-image, and my scale factor is less than 1. So let's take a look at some examples. Here I'm going to dilate the image around the origin with a scale factor of 1/3, and we're going to classify it as an enlargement or a reduction. Well, the easiest way to do this, guys, is to take the point, especially if we're going around 0, 0, take the point you're given, which in this case is 0, 5. 0, 5, and then multiply each of your coordinates by 1/3. This is 1/3 times 0, 1/3 times 5, or 0, 5/3. Well, 5/3 is a little bit less than 2, so B prime is going to land right here. Okay. Here, D is at the point, so D is at -2, 1. So we multiply both of those by 1/3 so that D prime is going to be at -2/3, 1/3. So -2/3 is about here, 1/3 is about here. So that right there is going to be D prime. Okay. So we've got our first segment right here. D prime to B prime, and you see how that segment appears to be about 1/3 the length of this segment. We're doing the right thing. All right, now let's look at C. Point C is at -6, 3. So C prime, multiply both by 1/3, gets me -2, 1. That's a lot easier. -2, 1. Oh, look, it's landing right where the original D was, but now it's going to be C prime. So now we have our second segment right here. Then last but not least, A is sitting at -6, 5. Well, we multiply both of those by -1/3, we get -2, 5/3. So he ends up at -2, 5/3, which should be even with B prime right there. So that's A prime. So do you see now, oof, I'm so connecting these poorly. Now we end up with a much smaller figure, right? It's definitely a reduction, okay? And with a scale factor of 1/3. So now let's look at our next one. Here I'm still going to do around the origin because that's a lot easier, right? And now I want a scale factor of 2. So we expect this to be an enlargement. Oh, I can't even fit the word there, can I? An enlargement, here, enlargement, because my scale factor is bigger than 2. Well, point A from my origin is at 1, 1, which means if I multiply those movements by 2, A prime is going to be at 2, 2, right here, A prime. B is at 2, 0. Well, when I multiply those movements by 2, I'm going to end up at 4, 0, right here. B prime. To get to point C, we went over 5 in the x direction, 2 in the y direction. So now I'm going to go 10 in the x direction, 4 in the y direction to get C prime. And then D was 2 in the x direction, 3 in the y direction. Well, now we're going to go 4 in the x direction, 6 in the y direction, which puts you way up here at D prime. And then all we got to do is connect our points, and we'll see that we actually make a figure. It's a similar figure that's just bigger than the previous figure. It's an enlargement. So let's take a look. If you're going around the origin, you don't even have to graph it to figure out where your new points are going to be. You just multiply each coordinate by the scale factor. So if I have points 3, 5, -2, 1, and 10, -4, and I want to dilate a dilation of 4, all I do is I multiply each of my points by 4. So 3, 5 is going to become 3 times 4 is 12, 5 times 4 is 20. 2, -1 is going to become -2 times 4 is -8, 1 times 4 is 4. And then 10, -4, multiply both by 4, 40, -16. Similarly, if we're doing it with a dilation of a half, that's going to be a reduction. And we're going to multiply each of our points by 1/2. This guy is going to become 3/2, 5/2. Guys, leave them in fractions. It will make your life easier, I promise. I know you don't believe me, but I promise. -2 times 1/2 is -1. 1 times 1/2 is 1/2. And then this guy here, 10 times 1/2 is 5. -2 times 1/2 is -2. So that's where my new points would end up. All right, let's take a look at this guy. Here I want to figure out the actual scale factor. So they've given me an original function, a pre-image, right? A, B, C, D, this guy right here, and then an image, A, B, C, D right here. Well, in order to figure out the scale factor, I really want to choose points that are easy to read. And looking at this, B1 appears to be the only easy to read point on here, and it's at 2. And I want to compare that all the way over here with B, which is at 8. Well, image over pre-image makes me think that my scale factor is 1/4. Well, let's take a look at that. C is at 5, 2. So when I multiply 5, so this is at 5, 2. When I multiply both of those by 1/4, I should get 5/4, 1/2. 5/4 is just a little bit bigger than 1, and 1/2 is, that looks right. We could check it with D too. D is at 1/4, so I would expect it to become 1/4, 1, which it does. So I think we have the right scale factor. All right, quick summary. Distance, the length of our segments are not the same. However, they are in a specific proportion, and each of the proportions is the same no matter which one you look at. And the length of a segment is equal to the length of the pre-image multiplied by the scale factor. My orientation does not change. My angle measures do not change. The concepts of parallelism, perpendicularity, collinearity, and midpoints, those are all in the same spots. The difference here is that we create a similar image, but not a congruent image to our pre-image. So guys, that is it for dilations, go ahead and take a look at the MML and have a lovely day.